Hi folks, I'm coming to you today to work with the technology portion for section 6.1. And with this technology portion, I'm going to use problem number 9 in eText from section 6.1. You'll notice that I worked this problem out in the Google Slides presentation that I sent out yesterday. However, I'm going to show the technology side of it utilizing StatCrunch. It's very simple. I'm going to open StatCrunch, and I see that in problem number 9, we're being asked to find the area of the shaded region. The graph depicts the standard normal distribution of bone density scores with a mean of 0 and a standard deviation of 1. Number 9, we are looking for the area to the left of the bone density score given as 0.44. I'm going to come over to StatCrunch now. When we come down to StatCrunch, just as I've shown in a previous video, Stat, Calculators, Normal. What you will see, as I've explained previously, the mean in this case needs to be 0. The standard deviation in this case needs to be 1, as we are working with the standard normal distribution. You will notice the field where we see P of X less than or equal to. If we choose that as a drop-down, you'll also notice that you'll see greater than or equal to. When we need cumulative area to the left of our continuous random variable x, we use less than or equal to. If we need cumulative area to the right of random continuous variable x, then we utilize greater than or equal to. The field I have just clicked on is where we will put the value given for continuous random variable x to be 0.44 for problem number 9 on page 240. We are looking to the left, so you will notice that I kept less than or equal to in my drop-down field for the inequality symbols. I'm now going to click Compute. You will then see the cumulative area represented as 0.6700, as shown in the Google Slides presentation yesterday. Let's look at one more. I'm going to take a look at problem number 11, which was one of the additional examples that was given in the Google Slides presentation yesterday. Coming back over to eText for just a moment. Number 11 reads similarly to what number 9 was asking for us to do as well. However, rather than a cumulative area to the left of random variable x, which is given as a z-score z, we're looking in number 11 for a cumulative area between two given values for z. Very simple yet again. We'll come back over to StatCrunch. But rather than use the standard calculator, we're now going to shift over to between. Mean and standard deviation, yes, are going to be exactly the same as previously given in number 9. We're going to insert our values for random variable x that were given as negative 0.84 as the lower limit value. Upper limit value was 1.28, so we'll insert that value there as well, 1.28. Now we will compute. After we compute, you will notice that we get a cumulative area under the curve at 0.69927. I believe I gave in that answer it to be, I didn't give you guys an answer. So here it is, 0.69927. 0.93 rounded to 4 decimal places, as you can see there. It's very easy. It's very simple. It's nothing horribly challenging to work with the normal calculator. Now, the other option that we need to consider is the option of working backwards. For example, number 13 on page 240, given in the Google slide. Let's come back over to eText for a moment. Hush. So going back to problem number 13 on page 240 is where we're going now. To illustrate the idea of working backwards. Basically, working backwards is getting us to think about finding continuous random variable x, which in this case is z, when we are given a cumulative area. So let's page over and take a look at number 13 as we see there on our screen. We're still working with a graph that depicts the standard normal distribution of a bone density score with a mean of 0 and a standard deviation of 1. Number 13 gives us a cumulative area of 0.8907. And we're being asked to find z. We're being asked to find z. So we're going to work backwards. It's actually, again, very simple to do. We're going to come back to our normal calculator in StatCrunch, but we're going to click back to our standard calculator, and let's remove some of the values that were already given in our field. Now, you'll notice that number 13 gave us cumulative area to the left. It's giving us cumulative area to the left. So what we'll need to do from here is to come back over to StatCrunch, make sure our mean and standard deviation are still showing 0. Likewise, make sure that our inequality symbol is showing less than. But rather than put a value in the field for random variable x, we're going to insert the cumulative area in the field to the right of the equal sign. We will insert there 0.8907. When I click compute, the value that gets returned is the value for random variable x that matches the cumulative area that we were given. And that cumulative area was 0.8909. Random variable x value that matches becomes 1.23, as shown in the Google slide that was given yesterday. Number 37 in eText that was given on page 241. So let's page over. They're asking us to find bone density scores yet again, but they're terming it and framing it in the lens of a percentile. We can find percentiles using the normal calculator if we know that the data distributes itself in a standard normal distribution as described for number 37. They're asking us to find the 99th percentile. This would represent the bone density score separating the bottom 99% from the top 1%. The drawing for this problem was included in the Google slides sent out yesterday. So basically, what they are giving us is the cumulative area under the curve as 0.99, which would read to the left, or 0.01, which would be cumulative area to the right of the desired bone density score. Let's come back over to StatCrunch. If you again refer to the drawings sent out in Google Slides, we can utilize the normal calculator yet again. I am not looking for cumulative area because it's already given as either A, 0.99, or B, 0.01. If we use 0.99, that would give to the left of the bone density score. Going back to remember, what is a percentile? It's that value that separates the bottom 99% from the top 1%. In this case, we are going to use 0.99. And if we click compute, you will see the bone density score that matches is 2.33 rounded to 2 decimal places. However, if you chose to use 0.01, you would change the drop down from less than or equal to greater than or equal to. And rather than use 0.99, we're going to use 0.01. Then click compute. Notice it's the same value, 2.33 rounded to 2 decimal places. And again, you may ask why. Well, we know that the normal distribution is symmetric about the center, meaning equal parts to the right of center, equal parts to the left of center, which again, we can utilize this information to our benefit as we work with the standard normal distribution. I hope you found this video to be helpful. Again, if you have questions, concerns, please feel free. Reach out to me via Remind, reach out to me via Moodle Messenger, or email, and I'm happy to work with you and help you out. We could try a Google Hangouts type session to answer any questions you may have face-to-face in a virtual environment. Take care. I miss you guys, and I hope you're doing well. Look forward to seeing you soon. Goodbye.